The lesson objective of this video, students will use perpendicular bisectors to solve problems. So a perpendicular bisector is exactly what it sounds like. It's a segment that bisects and is perpendicular to a side on a triangle. So if it bisects it, that means it's going to the midpoint and it's perpendicular. So some vocabulary words you're going to need to know. Concurrency is when three or more lines intersect at the same point. And it turns out that for perpendicular bisectors, we have concurrency. The point of concurrency for the three perpendicular bisectors of a triangle is equidistant from the vertices. So if we have point P here, it's the point of concurrency for the perpendicular bisectors. What we call that is the circumcenter. In other words, it's the center of the circle that would be circumscribed around the triangle. And because it is the circumcenter, I know that AP, BP, and CP are all congruent to each other. So the point of concurrency is equidistant from the vertices A, B, and C. The perpendicular bisector theorem says that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So in my figure here, I can see that it's a perpendicular bisector because AB has been bisected. AP and PB are congruent to each other. And it's got the mark for a right angle, so I know it's a perpendicular bisector. So if CP is the perpendicular bisector of AB, then I know that CA is going to equal CB, because C is a point that is on the perpendicular bisector. The converse is also true. If a point is equidistant from the endpoints of a segment, then I know it is on the perpendicular bisector of that segment. And so in this figure here, if DA is congruent to DB, then I know D lies on the perpendicular bisector of AB. So we can use these properties to solve problems. So let's have some examples here. In example 1, I have that AC is the perpendicular bisector of segment BD. And so that means that point A is going to be equidistant. So this segment has to be congruent to that segment because it said it's the perpendicular bisector. And so I know that 7x minus 6 is going to have to equal 4x. And so then you just subtract 4x from both sides and add 6 to both sides. And I get that 3x is equal to 6, so x equals 2. So in order to find the length of AD, then I just go back and plug it in to 4x, so 4 times 2, and so AD would equal 8. Another kind of problem you might see is one like this. We have that KN is the perpendicular bisector of JL. I want to know which segments are congruent, and then whether point M would be on KN. So first of all, let's see what I know based on what they've told me. They've told me that KN is the perpendicular bisector of JL. So I know that JN is congruent to LN. And I also know that JK is congruent to LK. Because any point on the perpendicular bisector is going to be congruent. And then I look in my figure and I see that JM and LM are congruent because they have the same measures. So the first one I knew because of the definition of a perpendicular bisector. Next one I knew because of the perpendicular bisector theorem. And the last one I knew because of the equal measures, or the definition of congruent segments. All right, so would M have to be on KN if we extended it out? Yes, it would. And I know that it would be because JM is congruent to LM. And that's actually the converse of the perpendicular bisector theorem. So the perpendicular bisector theorem tells me that any point on the perpendicular bisector is equidistant from the endpoints of that segment. And the converse says that if I have points that are equidistant from the ends of the segment, then I know it would lie on the perpendicular bisector. Okay, one more example here. I'm given that G is the circumcenter of the triangle, and BG is equal to 7. So if it's the circumcenter, that means that because G is the point of concurrency of my perpendicular bisectors, it's equidistant from the vertices. So anything from point G to the vertices would have to be the same distance, and so GC is equal to 7, and AG would also equal 7. And these would all be right angles. And these sides would be congruent because it's a perpendicular bisector. So if I were to tell you that GF was equal to 4, would I be able to find the length of FC? Well, because these are perpendicular bisectors, I have right triangles. And whenever I have a right triangle, I can find a missing side using the Pythagorean theorem. So yes, you could find the length of FC. Because I know that a squared plus b squared equals c squared. So 4 squared plus fc squared is going to have to equal 7 squared. So 16 plus fc squared equals 49. And we subtract 16 from both sides. So fc squared would equal 33. And so FC would equal the square root of 33. And that concludes this video. Thank you for watching.